Thank you very much for the introduction, and thanks for everyone attending this session. Friday at 8 a.m. is probably not the best time to present, and I deeply appreciate that from the in total 14 different talks that you currently miss, that you chose to attend this session, and hopefully you won't regret that you didn't get the extra sleep today. So what do we know about fat metabolism and fat oxidation rate? Fat oxidation allows for something called metabolic flexibility, so that we don't have to rely purely on carbohydrates during exercise. In terms of performance, it explains about 12 to 14% of ultra endurance performance in ultra triathlon and ultra running events, so it's an important parameter. It has been shown that maximum fat oxidation is associated with cardiorespiratory fitness in terms of VO2 max, and it is highly influenced by certain variables like exercise intensity, exercise duration, nutritional status, and probably sex. But there are inconclusive findings regarding the influence of sex. So if you had to decide if females or males have a higher fat oxidation, it's probably not an easy choice to see which one has higher values. Especially since fat oxidation has basically two different characteristics. One is the Y component, so how many grams per minute can you oxidize, MFO, maximum fat oxidation, and the corresponding velocity, usually referred to as fat max. This can be in absolute terms or as a percentage of VO2 max. From previous studies, and highlighted, you see where females or males have higher values, you see that there's quite a variety. And yeah, so the question arises, is there a difference in maximum fat oxidation and fat max between trained males and females with a similar VO2 max, since we know that this is a parameter that's influencing fat oxidation. So what we basically did is we took studies from an already published study. You find a QR code for the open access article. And within this study, we did several performance measurements, and we took a subsample in the following manner. So we had a total sample size of 44 males and females, 15 females, 44 in total. And we applied something like a filter, you could say, that we only included participants with a VO2 max between 55 and 63 in order to get an equal size of people with a comparable VO2 max, so 10 females and 10 males were included in this study. I won't cover all the things in details what we did in the big study, but I want to tell a little bit more about the graded exercise test that we used to determine maximum fat oxidation rate and fat max. We also did a RAM test in order to get VO2 max. If you are interested in the exact protocols, I can show you later on if you want. So how did we determine maximum fat oxidation and fat max? First of all, we calculated fat oxidation based on a certain formula, based on VO2 and VCO2. And we only included participants that had, we used a regression model, a quadratic polynomial, second order, and we only included participants that had a R-square of at least 80%, so had a good fit to this model. We used this kind of equation in order to interpolate between the points and rearrange the formula to get the corresponding intensity. And if we insert this velocity, then we were able to calculate maximum fat oxidation. Regarding our results, we found quite a lot of significant differences between males and females in terms of benchmark metrics. For example, mass, height, BMI, and so on. The only thing that was not significantly different between males and females was relative body fat percentage, which was closely to 13%. So now I would like to focus on the most interesting results of this talk. Is there a difference in maximum fat oxidation rate? No, we didn't find any. And even if it's, sometimes it's in grams per minute, sometimes it's in milligrams per minute per kilogram fat-free mass, and even then we did not find any significant difference between males and females. The same applied for fat max in percentage of VO2 max, but also if we use fat max in terms of the absolute velocity, the corresponding heart rate, corresponding ratings of perceived exertion or lactate concentration, again, no significant difference between males and females. And the same applied to other physiological variables like maximum oxygen uptake, maximum lactate accumulation rate, or the velocity corresponding to 4 millimolar lactate concentration. So these are basically the main findings. If you want to take a picture, it's a good opportunity now. So how do these relate to other studies? You can see here that we had a tendency that males demonstrated a slightly higher fat oxidation on average. However, it was not significantly different. And compared to other studies, we found a quite larger fat max, which can be due to the fact that our participants were fairly trained in terms of VO2 max compared to other studies. But there are a lot of things that should be taken into account, since these variables that you see on the slide all influence this chart. And hopefully I cannot talk about all of them, but I want to focus on some in particular. In terms of fasting and meals, we know that if we have a fasting period of probably greater than 5 hours, fat oxidation rate seems to be higher. In our study, we just applied 2 hours of fasting, but we did not control for it properly. We also had quite a variety of time of the day, so we did not only test in the morning, but also in the afternoon. So this is definitely something that could be more standardized in future studies. Since the study was conducted in 2019, we did not control for menstruational cycle. If I would do this again, I would definitely record it. We just know that they were not in menstruation phase, but from the other phases we can't really tell. And in terms of the metabolic cart, Bas van Hoorn did a great job with his colleagues to analyze different metabolic carts and if they are valid. And in terms of that, the model that we used was actually an older one, but the newer model gained fairly good agreement with in terms of VO2 and VCO2. So in conclusion, maximum fat oxidation and fat max seem to be similar for equally trained females and males, and this indicates that training status seems to be more important than sex per se. However, there is a lack of proper standardization, since this was not the main focus of our study. So as I just mentioned, fasting, time of day, or the menstruational cycle should be standardized. And from the data given, there seems to be a need for international standards regarding the protocol, data analysis, reporting, and everything else. But remember, all I'm offering is the truth from a subsample, nothing more. Thank you very much for your attention.